Hope I'm audible. Yeah. Okay. Thank you, Robin, for the introduction. Hey, hi everyone. Hope you are having a good day. The whole day has been packed with a lot of informative sessions and great speakers and all about CNCF and Kubernetes. So that's I like something very much. It's not almost everything about AI, unlike what is currently going on the boom. So yeah, I'm Imran, working as a DevOps engineer at Convin AI, and my topic is setting up hybrid workloads with Istio and Kubernetes. So I have a very interesting demo at the end of this talk. So I'll just run through the slides so that we can get the overview of the components involved during this demo, so that you can get a very good idea of what exactly is happening. So this is the agenda. So why workloads on VM in the first place, right? And we'll see a bit about service mesh and Istio, and we'll see the components, the gateways in Istio that are responsible, present in this demo. And we'll also see about the custom resource that are supported from Istio, the workload group and the workload entry. And finally, we'll have the demo and the simulation. Yeah. So why workloads on VM in the first place, right? So I believe there are 4 primary reasons why there are still workloads running in VM. One of them being the legacy application, that there are multiple companies out there who still rely on their legacy applications that are running on VM, and they're very reluctant to move it directly to Kubernetes, right? And second being security and compliance. A lot of companies adhere to the strict policies of running VMs in their particular network on a certain VM, a certain OS, so that they are kind of bound with the operating system. And third being, which is basically continuation of the first one, gradual migration. So a company which is growing from a monolith to a microservice architecture, right? So they cannot just directly jump into Kubernetes as of they cannot do it directly. They need a very gradual migration. They require a lot of breaking of stuffs and then deploying it to the Kubernetes, right? And last being, I believe most of the guys will also agree who are working in production with Kubernetes, that Kubernetes is not that good platform to run stateful workloads. VM are much more better for running stateful workloads as compared to Kubernetes. So these are I believe, the 4 primary reasons why a user wants to run workloads on VM. So moving on, service mesh, Istio. So how many of you have been using Istio in their production? Can you please give me a hands up? Great, that's okay. That's a wonderful crowd I am having right now. So service mesh is basically an extension hand of that we can give to Kubernetes for its networking capabilities, observability, traffic management, and resilience. Like the basic features of a service mesh, right? And the way Kubernetes is the de facto standard for container orchestration, I believe Istio is the same for service mesh. So yeah, Istio extends Kubernetes to establish a programmable application over networks. So that is a definition I just got from their own website itself. So currently, Istio operates in 2 modes: sidecar mode and ambient mode. Sidecar mode, it's self-explanatory. Container runs parallel to the workload that you're running, and it acts as an intercept between the traffic that comes and goes out of the workload, right? And the second one being the ambient mode, that is something they have come up recently with. They are still productionizing it. It's going good. But yeah, sidecar mode is the most stable mode, and pretty much all the advanced networking capabilities can be implemented using sidecar mode of the Istio. And we'll see the gateways that are present in Istio. The same way, you guys must be also using Nginx, right? The ingress controller. Istio has components which are pretty much similar to ingress in Nginx. So we'll just bit of compare and contrast. So in my current demo, there are 2 gateways involved, but in total there are 3: ingress gateway, egress gateway, and east-west gateway. So the ingress gateway is which is something similar to ingress on Nginx, Nginx controller. It acts as the entry point for the traffic coming to your application. You can see from the diagram as well. The user goes through the ingress gateway. The user request goes to the ingress gateway, and all the traffic is served to your workload, right? So it is something pretty similar to Nginx, how Nginx ingress controller works. And the second one, the east-west gateway. So this gateway is something pretty much different from ingress gateway. It acts as an entry point for workloads that are running outside of your Kubernetes cluster, the one I will be showing in the demo as well. So through this gateway, the external workload will be able to access the internal DNS of the Kubernetes seamlessly. You have this fully qualified domain, right? The service name, the namespace name, SVC cluster local, and the port address, right? So through this east-west gateway and the setup that you need to perform for this workload to be accessible inside the cluster and vice versa as well. So this is the entry point and the exit point as well for the traffic going in and out from the cluster to the external workload, right? So these are the two gateways that I'll be demonstrating I'll be showing up in the demo. So that is the two I am showing here. So, and yeah, coming to the custom resource workload group and workload entry. So workload group is something like the way you provide the pod template in the deployment manifest, right? You basically define the template, how the pod is gonna run, like what all environment variables, what sort of service account, and all the necessary stuff that are required. So you give that in the pod template. So workload group is something similar to the external VM. So we just define the template of what all details are to be registered when the VM is connected to the cluster, right? So that is something I can give reference with a deployment manifest pod template to workload group in Istio. It's a custom resource provided from Istio itself. So the way deployment is for deployment, summons pods, right? The same way workload group summons workload entry. In workload group, you define the template, and the result is workload entry. So what is exactly workload entry? The VM or the external workload that connects with your cluster, that comes as a workload entry. And workload, as I mentioned earlier as well, the workload group, you basically define how the external VM is going to connect to the cluster. And yeah, so we have come to the demo time. Before jumping into that, so this is the sample application that is already been deployed. So I'm using Ingress Gateway for the entry as an entry point for the application. 5 primary components: data service, UI service, image service, and the data is served from MongoDB, and the images are stored in Minio as an object storage, right? So I would like the people to open the live application right now so that I can demonstrate it. It may go, I think it will go, I'm not sure again, it may crash, but yeah, it will be live definitely. Please go and open it. Just give me hands up if you're able to open it. Great. So as I mentioned earlier, if I come back, so the data service is getting so it's a sample, animal album. So you can see the pictures of animals and their, some data about them. So the data is coming from MongoDB, okay, and the image URLs are coming from Minio. So to show this demo, currently everything is deployed in Kubernetes itself. So if I can show you over here, right, towards the right is the Kubernetes. If you can see the Kubernetes, I'm running on Google Kubernetes Engine as the Kubernetes cluster, and I'll be using an instance of VM in the Google Cloud itself to show that it acts as an external workload. So currently, if you see all the deployments that are running in animal album namespace, the data service, image service, and the other ones, right? Everything's working as of now, right? Is it? Right? Okay. So what I'm going to do right now is I'm going to scale down the data service, one of the service primarily responsible for the application to work. Can you please just refresh the page, let me know if it's working or not? It shouldn't work the very moment I scale it down, right? So what I'm going to do right now is, this VM I have configured to act as an external VM. The details are quite long, so I have skipped that part. There's a detailed article I have written on that. In fact, I'll be showing you the URL as well, so that you can also replicate the same and get the same out of it. So for that, what I need to do is, I need to start the Istio service in the VM. So it will take a moment. So if you see in my Kubernetes cluster towards the right of the screen, if I do get workload group in animal album namespace, I have already deployed the workload group, that is data service, the same one that I showed you in the presentation, right? The same workload group is deployed. right? So what I'm gonna wait for is the workload entry that will be the VM itself that will connect to the Kubernetes cluster. It will take a moment. Let's hope it comes. It takes a while for that to be registered. Yeah, you can see the workload entry has connected with the Kubernetes cluster. If you see the IP address 10.160.15, and towards my left is the, I'm not sure if this is present, no. If you can see the IP address over here, it's the same IP of the VM that is connected to the Kubernetes cluster. So what I'm going to do right now is I'm going to run the data service as a normal Python file here in the VM itself. And also, if you remember the architectural diagram, the data service was responsible to hit Mongo service and get the data and fetch it to the UI. So Mongo is not running in the VM. Mongo is running in the Kubernetes cluster. Only the data service component is going to run in the VM. So what is going to happen? The traffic comes to the Kubernetes cluster through ingress gateway. It goes out to the external VM for data service. Again, data service callbacks to the MongoDB and fetches. So the whole setup is just to demonstrate that how easy it is to connect the external VM which has both ingress and egress traffic linked with the Kubernetes cluster itself. Okay, now you guys can just refresh the page. Things will start to work. In fact, the logs are also coming up here, right? Things working, right? Yeah, that was the, I believe, the most interesting part, that, yeah, the external VM itself is able to communicate with the Kubernetes cluster for both ingress and egress traffic. So again, as I couldn't, it takes a time to, set up this external VM as a workload, because you need to generate some artifacts, which, also, the main thing is the traffic is going over public as of now, just to make it much lighter. But definitely you can keep the entire traffic bound to the cluster and the VM itself. And yeah, that's pretty much. And also, I have a detailed article on that, on how you can set up things. If I can show you. Yeah, so this was live. So I have given the link to this, the article, detailed article of how you can set up the entire setup, this external VM with the Kubernetes cluster working around, and you can definitely give it a read. And if you find any difficulty setting up, you can definitely ping me. If I'll be happy to help. Also, one more thing I missed mentioning about is this east-west gateway, right? You must be thinking, if it's public, then anyone can come and hit to the Kubernetes cluster. So that is the beauty of Istio, that it is also responsible for the authentication and authorization of what calls are being made through the east-west gateway, right? So all this setup has been configured on the VM, so that is why it is able to communicate without any drop of packets, and can say any authentication error as well. Do we have any questions? I have almost a minute now.
I think we'll not do questions.
Sure, that works. Okay. Yeah, so that's pretty much from my side. Thank you.